Our designated project is energy from the sea. We decided that we're going to build a tidal barrage, and our group consists of Ben Ferrimond, Harry Hobday, John Edwards, Libby Dooher, Tom Dulake and Will Cowen.
What is a tidal barrage? It is a dam situated in a tidal river. It traps water at high tide and then releases it at low tide through a turbine and generator to transfer energy.
Determining the location of the barrage was very difficult. Several estuaries and rivers were protected as national trusts. Others had high levels of traffic due to inland harbours. This would have meant the barrage would have to be left open a lot of the time, which would lose a lot of power. The River Severn is situated in the west of England. It separates England and South Wales. The Severn is the longest river in the British Isles. Its source, which is in Wales, passes through several counties in both Wales and England before entering the Bristol Channel. There are already several crossings over the River Severn, the Severn Bridge and the second Severn crossing. Both bridges span the River Severn, with the longest bridge at almost 5 kilometres. The original idea was to build the barrage underneath the bridge. By using the already existing structures, the costs and times needed to construct the barrage would be significantly reduced. However, it was decided that it would be more efficient to have the barrage further downstream, where the water volume was far greater. With the addition of another bridge in the form of a barrage, the volume of traffic on these two bridges can be reduced. Also, with several closures over the past years of both bridges, we believe it is a good idea as an alternative. Plus, a toll on this barrage could produce a high level of income.
Some basic stats about our proposed barrage. It would be 10 miles long and stretch between Lavernock Point in South Wales and Brean Down on the north coast of Cornwall. It will contain 214 40 megawatt bulb turbines, producing a total max power output of 8.6 gigawatts, with an average of 2 gigawatts, and reduce UK carbon emissions by 16 million tonnes per year, equating to 3%. The current biggest barrage in the world is the Siwa Lake Tidal Station at 254 megawatts. Ours will be nearly 40 times bigger than this at 8.56 gigawatts. It would generate 5 to 6% of the current electrical supply for England and Wales. It will be the equivalent of 8 coal-powered stations or 3 modern nuclear facilities. The annual output, 17 billion kilowatt hours. Why the Severn? It's by far the biggest barrage concept in the world. With tidal range up to 14 metres, it's the second largest of any river in the world. Lorance, built in 1966 in France, has 24 10 megawatt bulb turbines with a max power of 240 megawatts. 600 million kilowatt hours output per year, and its cost has since been recovered.
Gravity buttress and arch dams are usually made from concrete with steel reinforcing in them. The embankment dam is made up of earth and rock. Gravity dams are the larger of the 3 concrete dams as they rely on their weight to hold back the water. It is also the more expensive of the dams because it requires so much concrete to build them. Buttress dams can be made either curved or flat. The reason why they have their name is because they are braced using a series of supports on the downstream facing side of the dam. Arch dams are thinner and require less concrete than gravity dams because the way they are designed means that they transfer the forces from the water into the foundation. Arch dams are curved so that the curve is facing downstream. This means that as the force of water is applied, the dam compresses and strengthens. Embankment dams are usually made up of the earth and rock that is excavated during the preparation of the site. They use an impermeable earth or clay core so that the water can't get through. The rest of the dam can then be made up of the same material or rock. Concrete dams have a solid concrete foundation which the base of the dam is poured and connected to. The rest of the dam is made up of a strong concrete and a lot of reinforced steel, which is laid in a crosshatch type pattern to add strength. We will look at the best mix design of the concrete in the later designs. Embankment dams are made using the excavated material and, if needed, other materials brought in. The rock that is removed from the spillway tunnel is also used. Embankment dams are usually made of permeable rock on the outside but have an impermeable core such as clay. How a dam is built. Well, the first step in building a dam is to divert the water. This is usually done by a spillway, which takes the water from upstream of the site, around where the site is to be built, and then reconnects it with the river further downstream. Engineers usually do this by drilling holes in the rock, placing explosives in the holes, and then removing it once it has been blown. Once the spillway is complete, the river is then drained through it so that the site area is clear. Temporary small dams are set up both upstream and downstream to the site, so water can't flow back into it. Any water still left in the site is then pumped out. Huge holes are then drilled into the rock on the bed of the river, and a mix of cement and water pumped through them to act as grout and join the rock and strengthen it. Reinforcing steel bars are also driven into the rock bed that will later be tied to the reinforcing in the dam, which will help secure the dam to the bottom. Forms that can be made out of either wood or steel are then built along the edges of the foundations. The reinforcing steel is then placed in and tied to any steel in the foundation. The concrete is then poured in and allowed to set. The construction of the dam is continued in this process. The process takes time because only small sections can be concrete at a time due to the time needed for the concrete to set enough to be able to take the weight of the next section. As the dam gets to certain heights, the structures are put in, such as the turbines and generator rooms.
The bulb turbine is the most efficient turbine currently in use today. It can produce up to 10 megawatts of power from small heads of water. It is also up to 25% more efficient in size and cost than traditional turbines in use today. The Francis turbine needs large heads of water that can handle huge amounts of stress, The Francis turbine needs large heads of water that can handle huge amounts of stress. This means the output of power is greater than others, maxing out at around 800 megawatts. Solid. The Pelton turbine, just as the Francis turbine, operates in large heads of water and can produce up to 350 megawatts.
A reduction in tidal range from the barrage holding back water decreases the area of the salt marsh, mud flats and sand flats around the barrage. The effect of this reduction in area from the salt marsh would affect the birds and the plants. In the mud flats, the reduction would mainly affect migratory birds and invertebrates, and with the sand flats it would affect the invertebrates. The loss of land from the mud flats and the salt flats could damage up to 30 species of birds that feed there. The Severn has over 100 species of fish. Among them is the Atlantic salmon, which is one of the main types of fish that would get affected by the turbines. Because they are very large, they would get caught in the blades and die. The turbines could cause local extinctions of these fish, and that would be bad for the ecosystem. The direct effect of the turbine is the fish getting hit by the blades or getting disorientated by the water pressure around the turbine, and this causes damage and disorientation to the fish. And for fish mortality, the indirect effect is the loss of habitat where the fish are feeding and reproducing, so it would damage the fish's ecosystem. Other environmental impacts are the carbon output when the turbine and the barrage is actually being built. The building and transportation of the turbine and materials would contribute largely to the carbon output of the barrage. This would hopefully be offset by the green energy produced in the barrage. And with the wall layout, the road would be about 10 miles long, so it would be highly unlikely to be used as a pedestrian's walkway, but there should be a two-way bicycle path so that bikes can cross from one side to the other. The barrage would become like an attraction, like the Larance tidal power plant in France. This power plant has about 70,000 visitors a year, and we should accommodate this by having a building dedicated to the barrage for information on hydroelectric power and what the barrage is doing. with the road on top of it, the road lights should be about 20 to 25 metres apart so that the road is well lit. For every 20 to 25 metres, there'd be a light, so that'd be 80 lights in a mile and 800 lights for the whole 10 miles. These lights would be run off the power generated by the barrage, so that the whole thing is self-sufficient.
The Gantt chart is a method of keeping our progress on time and up to date for future deadlines.
The research that has been obtained will be used in the designs of a barrage that will be at the River Severn. Different designs will be produced and a final design will be decided on. A report about this will be produced including a virtual and physical model of the barrage.